Hi, hello, welcome to VHTL Basics. Today we are going to see about latches versus flip-flop. Latches and flip-flops are sequential logic circuit used to store and remember information in digital systems. They are fundamental building blocks in digital design and plays a crucial role in the implementation of register, memory element and state machines. So in this example, I am going to explain about D-latch and D-flip-flop, and we will compare latch with respect to flip-flop. So this is the symbol diagram of D latch. Here if you see D and enable E are the inputs, Q and Q bar are the output. If you see the truth table, whenever enable is 1, if D is 0, output Q will be 0. If D is 1, output Q will be 1. Q bar is nothing but not of Q. And if enable is 0, with irrespective of D value, Q will Q will be in the remains Q will remain in this previous state actually. So this is the truth table of latch. This is the timing diagram of D latch. If you see D is changing here, but with respect to enable, if enable is 0, Q will be in previous stated value itself. So that's why it is remains 0 here. Here enable is 1. Here if you see data D is going high. Here enable is going low. So enable is low means Q will remain in the previous state. Here previous state of Q is 1. So it is maintaining that value here. Again enable is going high. So here D is 0. So it is Q also going 0 here, and here D is high, then Q also going high. So like that latches will be on level trigger. With respect to the enable, it will transfer the or store the data in this element, memory element. This is the simple diagram of flip-flop. Data, clock are the input here, and output Q and Q bar. If you see the truth table, whenever clock is going for rising edge, at that time, if D is 0, then Q also will become 0. If D is 1, Q also will become 1. Other than the rising edge of the clock, irrespective of the D value, Q will remain in the previous state. Q bar is nothing but not of Q. Now I will explain the timing diagram of D flip-flop. If you see here the rising edge of the clock, if you see the D value, it is 0. So if you see here, Q will be remains in 0. In this rising edge, data is high, so Q also will become high. In this rising edge, it is 0, so again Q will going to 0. So like that, whatever value present in the D with respect to the rising edge of the clock will be stored for one clock pulse in the flip-flop. This is called D flip-flop. Now we can see latches with we are going to compare latches with respect to flip-flop. If you take this structure, latches are level sensitive device, meaning their output changes as long as enable input is active. They typically consist of cross-coupled NOR and NAND gates. On the other end, flip-flops are edge trigger, which means their output changes only when the clock signal transition from one state to other. So flip-flops are constructed using combination of logic gates such as NAND gates or NOT gates. If you take the timing with respect to latches and flip-flop, since latches are level triggered, they are sensitive to change in the input levels throughout the entire duration of enable signal. This can lead to potential timing issue, especially in complex circuit, as the output may change unpredictably based on the input signals. Flip-flops, being edge-triggered, are synchronized to the clock signal and update their output only on the clock edges. This provides more precise timing control and avoid glitches that can occur in the latches. If you take the stability, latches can enter a metastable state when their input changes near to the transition of enable signal. This metastability can cause the unpredictable output behavior until the input settle down. Flip-flops, however, have inbuilt mechanism to avoid metastability, such as master-slave configuration or additional circuitry, making them more stable. Applications. Latches are more commonly used in application where continuously monitoring of input signal is required, such as bus interface and pipelines. They are also used to building blocks of constructing flip-flops. Flip-flops, on the other hand, are essentially used in synchronous system where data synchronization and precise timing are crucial, such as in processor, memory element, and state machine. Overall, while latches and flip-flops serve similar functions of storing and remembering the data, their operating principle and timing characteristics and stability properties differ significantly. The choice between latch or flip-flop depends on the specific requirement of the digital system and the desired behavior of the storage element. Latches and flip-flop both can be synthesizable. When it is coming to meeting the timing, it latches will be little tough to meet the timing in STA analysis. In case of flip-flop, it will synchronous with respect to clock. So the STA will not cause much problem when you are using the flop in your design. So thank you for watching this video. Please like, share and subscribe this channel for more videos.